Hello everybody, Brian here from quantlabs.net. Okay, so I just wanted to show you a script that I've run. It's basically a linear regression script which basically calculates this RMSE and predicts price moves. So let me show you the source data. This can be also used for trading. So here we have two, basically, well, really everything comes down to X and Y on your chart. You know, price versus timestamp, or time series. So when you look at this code that I've downloaded, the reason I chose this script is for a variety of reasons. This is the source of it from machinelearningmastery.com. Historically, let me just say this. When I start seeing, I'm by no means a mathematician. I do know that 1 plus 1 equals 3, and 2 plus 2 equals 4. Or no, is it 5? Anyways, I'm no mathematician, but I do know my math. Anyways, this RMSE, which I'll go over in a minute what it is just a typical timestamp, as I've shown you in that data source here. X, Y, whatever. But when you look at this, this would be a typical. Actually, sorry, this is a data set here. This is Python, just so anybody knows. And there are two ways you can approach this. This is before. As I said, I've looked at this well before the term big data, the term machine learning came along, or even now artificial intelligence. This right here, again, I've used in MATLAB and played with it years before any of those terms came up. So to me, it's not really, this is not machine learning. This is just math. And there's no dependencies in this whatsoever outside of the square root. That's it. So everything's all pure math. So what we're dealing with here is we have data, let's say a timestamp. We evaluate the algorithm, and the algorithm, so there's two things we're looking for that we can find. The predictors and the RMSE, which is this. Calculate the root mean squared error, which is a measurement of, can we do something with this data? Is it predictable? Well, let me show you here. There's a couple of things I want you to take away. First, we have evaluate algorithms. So in here, you'll find, as I said, we only have one dependency. All the successful high-end 7, 8, 9-digit guides that I've experienced over the years will not touch any form of libraries. Everything that they write, they develop is 100% developed by themselves because they know the code, and they can rely on the data that it produces. It's not some third-party, unknown, something that was, I would say, GitHub, which Microsoft just bought. But anyways, that is from what I always refer to Cousin Johnny wrote. So you don't know if that data is good, and the result of that data is wise to use and to interpret from to make a trading decision. So as a result, most of these guys that I've talked to, and dare I say, females are starting to come into this. We want more of them, for sure. But they're there. Anyways, what we want here is the ability to not use dependency code. We write it ourselves. So all of the code you see here is math generated within this script. So we have our way of calculating mean. We have our way to calculate covariance. We also have a way to calculate variance and measure our predictors, which are coefficients. So let me just make sure I'm very well known for making mistakes here, because as I said, I'm not the, let me just see here, where are you? I'm just going to look for a print. Where's our print statement? So we have here an RMSE, oops. Okay. So what we have here are, as I said, what we call the predictors. What are those? Well, as an example, we have here algorithm, our data set, and our test set. So we do with the machine learning, no different. There's books that I've seen specifically from Robert Pardo, who has figured out the right way to do it. I don't know if it's the right way, but a popular way. We'll leave it at that, which I think is correct. You take your data set and you split up the data set, maybe 50-50. Usually it's 80% and 20. So you take your 80% for historical, and you take out the last 20% of that historical data. And what you do is you build your data set, you build an algorithm to predict it. So essentially, these are the parameters that you use to predict the moves. Which way, what will happen with the data, And this is what's generated here in the predictors. And this is what all machine learning, at least using linear regression, from what I'm seeing, does, is we build an algorithm, right? So we're building an algorithm from this, using the data set and the test set. So when we go into our algorithm function, let me just see if is there one? Or there's something wrong here. I do basic stuff. If it works, right? Whoops. Algorithm. Okay. There it is. There it is. Oh, I see. Wow. No. So algorithm is, oh, I'm sorry, that's a passed in argument, which threw me off. Okay, so we are looking at algorithm. So it's not calling itself. So evaluate algorithm. So this is our simple linear regression. Oh, these are the, so this is returning, I have to go through the code more importantly, but it looks like it's calling this returns into the, pass it in the argument. Hope you got your programming hat here. So here's our data set, and this is the result of the simple linear regression, that the results of that, and has put and passed it into the evaluate algorithm. So what I'm gathering here, here's the first call. We have our train and our set. So we have our list, or define it as a list. Run our coefficients on the training the data. Again, we're not using any form of dependency code here. This is all coded within this script. So this is the best way to do this. Now, if you want a tip from me, you'd want to run this through the a debugger. And if you haven't seen my visual code video, just make sure I can find that for y'all. Just so you know, I'm gonna have to shut myself up in a minute. Shut up. Yeah, I won. All right, so if you look up visual code, and I've only done this supporting one Microsoft product. We got Visual Studio. Visual code. Visual code. Anyways, it's somewhere in there. Out of the 2,000 videos, have fun. But in here, if you were to run that through a debugger, this is a great way to learn about not only machine learning, learn about actual programming, step by step, plus understand how the math is generated, how it's built. If you take out the dependency code and you use 100% of the math calls or functions within your own script, you'll learn a lot. So continuing along, we generate our coefficients. So what this is doing is creating the coefficients of this data, which is measuring the slope, which is another way of saying we're looking for a trend line. So that's where the B1 and B0 come in to measure that. And what I'm referring to there is simple, I'm not even sure if this is linear. No, this would be calculus, I think. So what we're doing here is, I don't even know if this is correct, if it's y, no, x equals ay, or no, I think this is what I was doing in high school. We're going back, well, quite a few decades. So this is the kind of formula we're using to measure slope. Yeah, this should help. A linear function, as if I'm an expert here. So yeah, this is what we're doing here, is we're measuring y of that slope of the y and x. So half x plus 2 in this case. So that's what we're essentially doing, is using and trying to figure out, in this term they call it B1 and B0, or the a and b of the slope. So generate those coefficients, which they call, am I right to say predictors? That's in the machine learning world. But again, if I'm wrong, please correct me. Don't insult me, but just say, hey, dude, you're wrong. Here's what. Just be nice. That's all. Because I laugh at people that try to be all mean and stuff. I just delete the comments now. So I don't care about them. Anyways, so that's what we're trying to calculate here on the coefficients. So that's what we're measuring right here. And that's our training data of the 80% of that data. Now, a book I mentioned that will be very helpful for is Robert Pardo, Walk Forward, I believe. I can't remember. It's been a while. Yes. This is the book I'm referring to. And I think this is the book that started the linear regression, because Robert Pardo, his book is all about forward testing theory. Again, I'm not a pro here, but this is linear regression. Take the 80%, measure the 20% to predict it, but use of the real data, that last 20%, to compare it to see if your algorithm is somewhat accurate. Okay, and that's what we're doing here, if that makes sense. So we go through the evaluate algorithm. Yeah, okay. Now, here's the thing. So we evaluate the algorithm. Let's go up to here. We have a list. We pump it through to calculate our new data set, our test set here. Now we have our algorithm, our data set, test set that we're using, and we have now our predictors. Right. Here's the ones that highlighted. And now we're using the actual, and that's the last 20%. So if you read this guy's book, out of all the things I've seen, this is the best one. And quite good as well. And then, guess what, folks? We are able to measure that RMSE metric of the actual data and our predicted data, that last 20%. And we get our calculation. We can make an interpretation of that. Yet to be determined from my point of view. But that's standard of how it's done. But the thing is, I want you to always remember, this is using 100% pretty well all the code and all the measurements yourself. So here's a couple of takeaways. When it comes to looking at not just data itself, when it comes to like things like pair trading or arbitrage, you're going to use a benchmark. And right now, the most popular benchmark, of course, is going to be the S&P 500. Fine. But if you're going to measure something like a Pepsi versus a Coke, you want to see if it's first. Is there any form of relationship there? Is there covariance? So that's what this measures here. And again, we have the code to understand using the data point minus the mean of it against the Y move as well, the timestamp. And we see if the pair are working in tangent and are covariant. Or is that right? I think so. There's some form of relationship. When they move up, do they move up together or don't they move? And the other thing is, when you get into things like fixed income, you're going to be measuring things like yield. One against the bund against the U.S. Treasury. And there's a lot of data you could take away from that. So the majority of this is a couple of things. Is this machine learning? Maybe in the world of machine learning people. But the unfortunate thing is it's funny to me when you get people that are not strong in math, not strong in computer programming or software engineering, let's say, just read a bunch of blogs and then they'll think that they're all of a sudden experts. They're not. But this is very simple stuff. This is the bane of, I guess, the equivalent of machine learning. But for linear regression, this is just pure math. That's all it really is. And to me, using this type of script is simplistic math. Well, it's not simplistic, but it's simpler than using some thing like TensorFlow. It'll probably take you weeks to find the equivalent of this in the library of TensorFlow. But all you know, it just pumps out an answer, and how do you interpret it? And it's okay, we can rely on it because, well, hey, it's from Google. But I think it's really important to understand the math behind it all, because I've seen it. Questions on Quora, they go, should I learn the math when it comes to machine learning, the underlying math of machine learning? And there's some people which baffle me and say, no, you don't need to learn. Just, it's okay. You can rely on the results of this thing called TensorFlow or Torch or whatever they call them. That's okay. I think it's wrong, but whatever. And then they'll come complaining and crying to you because they lost money, and you wonder why. So it's really important to cut out as much dependencies as possible, machine learning or not, and try to understand how to apply this from a quote-unquote machine learning, big data perspective, from a software engineering perspective, from a math perspective, to be able to properly interpret this for trading purposes. The guys that make the most, I would say the guys, the people that make the most amount of money at this, okay, the most amount, the optimal amount that they take away, they understand these relationships, and they're not going to happen 100% of the time. But they will, from time to time, show a relation that are always watched to see if they are going into some kind of correlation. And when they do, they use this stuff to measure, and then the pair will diverge. And you got to understand that. So don't rely on this 100%. Yes, it works only when the pairs that you're looking at actually are in some type of direct relationship. Even indirect is fine. But as you dig deeper into this, specifically on the math side, to really understand how that relationship is formed and why it's forming, and also understand the risks of that relationship to break down, is important. And the only way is to understand the math. On top of it's very important to understand on how, well, you just can't rely on 100% of the time. It just doesn't work that way. But I just want to show you a few really important things to take away from this type of script, specifically involving quote-unquote machine learning. This ain't machine learning, okay? This is math, basic math that existed probably decades ago, okay? And it's the math that drives a lot of this information of the trading decisions. But you still got to understand the software when it's passing data from one function to the next. If you use Python, that's another thing. But really what's important is to understand the trends in the trading world, why they may break down or why they may form, and when to look at them and when not to look at them. Because those relationships will make you money. That again comes back to my other video I just put out, to understand the trend, to understand, is there an actual buying signal here because of the average moves and the different types of average moves that price gives you over a certain amount of time. And always look for the optimal pair or optimal whatever you're going to get maximum profit at that point. So you don't tie up money that could either lose or not get as much profit as you could get in other pairs that you could trade. So understand that. And again, another big lesson from this is if you're really new to it all, take a look at the code, play with it, understand it, but most of all, run it through a debugger, feed it some fake data, or close to as realistic data you may have when it comes to a time series, pump it through this kind of script, and play with it. Understand the flow of the math, understand the flow of when you're passing data from one function to the next and what it does in the result. And then understand how to interpret that data to make your trading call or your trading forecast. Okay, really important stuff. And there's, as I keep saying, there's literally thousands of opportunities out there. Proof. Binance alone, just on one exchange, 315 cryptocurrency pairs to play with and to analyze. You get this faster, the better you'll be. Now, that's another thing I should talk about just for a little bit. I don't want to overwhelm you. I probably am. And you're probably holding a gun to your mouth because all this stuff makes you think you can't do it. Yeah, you can. Anyways, Python's really slow. This stuff is simple. I am now probably pushing the limits I can do with Python, which means I gotta open my eyes and figure what's the next best programming language to go with. And Gargy, that's C++, to get stuff like this done, because it's at the OS level, the operating system level, and you don't care about pretty charts, you don't care about pretty menus and pretty colors. That's crap. That stuff does not make you money. This, understanding the relationships, will make you money. So I'm now, at some point, trying to visualize how I can code this up in C++. And that's a whole other world as well. To understand memory management, I'm not going to get into that. But this is just Python's much, much simpler, much easier to break down, much more easier to fathom. I just wanted to mention that to you. And please, do God, don't call this machine learning, because it's been out for a long time. It's just, they like to stick fancy labels on it because it's, but this is linear regression at its simplest. All right, enough blabbing. Hopefully you're still here, and we shall talk to you later. Thanks for watching.